Hello students, peace be upon all of you. As you can see in the title of the video, in this video we are going to cover how to determine the volume of a rectangular prism and the volume of a cube. Now, how does a rectangular prism look like and how does a cube look like? So, we have a, let's try this better. We have a rectangular prism. There you go. There you go. This is what? This is a rectangular prism. Rectangular prism. What's another word for rectangular prism? Cuboid. You can also call it cuboid. Okay? Here we have what? We have a cube. We have that cube. Okay, this is a cube. Now, these two shapes are what? These two shapes are 3D shapes, meaning three-dimensional. Why do we call them 3D shapes? There's 2D shapes, two-dimensional shapes, and then there's 3D shapes, three-dimensional shapes. What's the difference between these two kinds of shapes? Well, we call this three-dimensional shapes because they have a length. L is the length, W the width, and they have a height, H. These kind of shapes, the 3D shapes, they have what? Length, width, and height. Or the rectangular prism. We call the rectangular prism a 3D shape because it has a length, a width, and a height. Same with the cube. It has a length, a width, and a height. We call them 3D because they have 3 dimensions. 1, 2, 3, 1, 2, 3. But something like a rectangle. This is a rectangle right here. Rectangle. Can we call it a 3D shape? No, it's not a 3D shape. It has a length and it has a width. So it's what? It's 2D shape. It's a two-dimensional shape. It has a length and it has a what? A width. So it doesn't. This has 3 dimensions, length, width, and height. So we call it 3-dimensional. All right. Now, each two-dimensional shape, each 2D shape has its own 3D version. Has its own what? 3D version. So this rectangular prism is a 3D. What kind? It's a 3D version of what? 2D. It's the 3D version of a rectangle. The 3D version of a rectangle. A cube is the 3D version of a square. 3D version of a square. All equal sides. Remember, a square has all equal sides. A rectangle doesn't necessarily have all equal sides. The length can be different than the width. So this is the 2D shape. This is the 2D shape. This is the 2D shape. The 3D version of a rectangle is the rectangular prism. The 3D version of the square is the cube. Okay, so this is 2D. This is 2D, right? Two-dimensional. But this is what? This is 3D. 3D. Why? Because this has a length and a width, two-dimensional. This also has a length and a width, meaning it's two-dimensional. But these shapes right here, they have 3 dimensions. Okay. Now that we know the difference between 2D and 3D, and that each 2D shape has its own what? Has its own 3D shape. How do we determine the volume of these 2D shapes? In this video, we're only going to determine, learn how to determine the volume of rectangular prisms and cubes, right? In other videos, we're going to cover how to determine the volume and surface area of other shapes. Okay, the volume of other shapes. Let's talk about volume for now. So, how do we determine the volume of this shape, of this 3D shape, and this 3D shape? Well, it's very simple. Remember how I said that a square is a rectangle with all equal sides. So a square is still a rectangle, but it has all equal sides. A rectangle, not calling it a square, just a rectangle, is just a rectangular shape that doesn't have all equal sides. All right. So saying that means what? Means that it's this cube is almost the same thing as a rectangular prism, except the cube has all equal dimensions. So the length is equal to the width is equal to the height. The length is equal to the width, equal to the height. All the 3 dimensions are what? Are equal to each other. In a rectangular prism, they're not necessarily equal to each other. The length can be different than the width can be different than the height. And you can even tell by the image here. All the dimensions look the same, right? And so, saying that they're almost the same thing, they have the what? They have the same way of finding the volume. What is the volume now? What is the definition of the word volume? What is volume? Volume is how much the 3D shape can hold, how much an object can hold. A 3D shape is an object. It's just an object. How much it can hold. A book is a 3D shape. A box is a 3D shape. All these kind of shapes that look like that is a 3D shape. All kind of objects that look like that are called 3D shapes. So volume is how much the capacity, how much your 3D shape can hold, how much what your 3D shape can hold. And you'll say you have some sand and you have a box, a 3D looking, a rectangular prism looking box, and you're trying to put some sand or pour some sand inside your box, and you want to determine what's the capacity of the box, how much it can hold. That means you have to find your volume. Your volume is how much your object can hold, how much it can go inside here, how much it can go inside here, inside your box. Okay? So volume V equals what? Equals length W times width, length L times width W times height H. Length times width times height. Length times width times height. Same thing was what? With a cube. Length times width times height. This is how we determine the volume. This is how we determine how we can find how much our object can hold, the capacity of our object. Okay, so the volume of our object is the capacity of our object. How much the amount of things it can hold inside here. Okay, or the space it has to pour things inside here. That's the volume. How much it can hold. All right. So the volume is how much it can hold, meaning we take the length times the width times height. That's how we determine it. Okay? Now that we know how to determine the volume for rectangular prisms and cubes, let's take that into action. Alright. You have a rectangular prism. There you go. And let's say the length is 6 meters, the width is 2 meters, the height is 4 meters. How do we find the volume? We said the volume V equals length times width times height. Awesome. This is length, this is the width, this is the height. So the length 6 meters times the width 2 meters times the height 4 meters. 6 meters times 2 meters, that's 12 meters squared. 12 meters squared. 12 meters squared times 4 meters is gonna be 48. 48 what? 48 meters cubed. Why cubed? Because the meters are being multiplied 3 times. The meters are being multiplied 3 times. If it was area, it's only meters what? Meters squared, because the units are being multiplied the units are being multiplied by itself twice, right? Like meters for area will be meters times meters, so it's being multiplied by itself, so that would be meters squared. But for volume, that's for area, right? But for volume, it's meters times meters times meters, meaning it's meters what? Cubed. Makes sense? So whenever we try to determine the area, we square what? We square the units. We take it to the second power. All right, but whenever we try to find the volume, we cube what? We cube the units, meaning taking the units to the power of what? Of 3. Remember that. So if this was area, it would be meters squared, but it's meters cubed. Why? Because it's volume. We're trying to find the volume. So length times width times height. We multiplied them and we got 48 meters cubed. And of course, if you have the volume and you have the width and height, you can find the length. If you have the volume and you have the length and height, you can find the width. If you have the volume and you have the length and the width, you can find the height, right? Because you know the formula, how the formula works. The volume equals to the length times the width times the height. All right? The cube, same idea. Let's try a cube now. This was a rectangular prism. Now let's try how to find the volume of a cube. We have a cube. How do we find the volume of the cube? Remember, a cube is a 3D version of what? This is a cube. It's the 3D version of a square. So if this is 3 meters, then this is also 3 meters, then this is also 3 meters. All the dimensions are equal. The length, the width, the height. Volume equals what? L times W times H meaning 3 meters times 3 meters times 3 meters. 3 times 3, that's a 9. 9 times 3, that's 27. 27 what? Meters cubed. If this was feet, it would be feet cubed. This is the volume of this cube right here. Alright, this is how you find the volume of rectangular prisms and cubes. Length times width times height. Alright? If you're missing one of them, you can find the other. If you're missing one of them and you have there's 4 things: volume, length, width, and height. If you're missing one of them, you can find it through the other 3, right? Alright? Just use the formula. If for example, he might tell you, oh, the volume of this is 20 meters cubed. What's the length? Well, you're going to say 20 equals length times, you must have the width and height to find the length. And if you ask him for the width, then you must have the length and the height to find the width. You must have the length, the height, and the volume to find the width. So in order to find one, if one of them is missing, you need to have the other 3 to find the missing one, right? So, but for the general formula to find the volume, to find how much it can go inside here, how much this can hold. Let's draw this in brown. How much this can hold? We need to find the volume, meaning length times width times height. Volume is equal to length times width times height. 3 meters times 3 meters times 3 meters. If this was a rectangular prism, you also do the same thing, but the dimensions may be different, right? I hope you guys found this helpful. If anything was unclear or confusing, please go back to that part that was unclear or replay the video. Thank you guys for watching. We'll see you next video.